Hello guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are absolutely free of charges. My courses are going to help the students who are preparing for CSIR, NET, GATE, NTA exam, PhD exam, SET exam, TIFR, IIT-Jam, Jest and other exams related to physical science. Okay, so this is the lecture number 3rd of thermodynamics and statistical physics. Okay, and also guys, I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures which are going to help you to crack the exams related to physical science. Okay, well, so let's get started. Okay, so we are going to I'm going to discuss thermodynamic process. Okay, and also so how to solve PV graph questions. Okay, so there is a question. I'll make a diagram first. Okay, and then I will explain it. Okay, so PV curve, area under PV curve means that is work done. Okay, so we know this is the P. Okay, this is the P. These are straight line guys, and this is PV curve we are talking. Okay, we need to find work done. Okay, so drawing the diagram. Okay, so this is the one. Okay, and then this one. Okay, so this is the figure, and this is A and this is B. Okay, this is 1 and this is 2. Well, and this is guys 0, this is V naught, and this value is 2 V naught, and this is P naught, and this is 2 P naught. Okay, right, this one. So now we have to find work done. Okay, work done from different process. This is a PV curve, and PV curve we know that work done is area under area under curve. Okay, area under curve, right, area under curve. So now we are going to choose two paths and then we'll find work done. Okay, for this part we are going from A to B. Okay, A to B by this path and by this path. First we will come to this and then this. Okay, so this is these are two paths, and what we are going to find, we'll find the work done by this path and work done by this path, and then we'll compare with work done, which work done is greater. Okay, so for first that this is the path 1, right, and this is the path 2. This is path 1 and this is path 2, and path 1 work done we are going to represent by W1, and path 2 work done we are going to represent by W2. Okay, so W1 is going to be, so work done W1 from going A to B by path 1, that is W1. Okay, work done W1 is going to be area under curve, right, area covered by this AB, and area covered by this AB is this complete area, right, means this triangle area plus this square area, right. So this is going to be like this. So this is this rectangle area, right. So this is going to be area of triangle plus area of rectangle, right. I'm writing in short. So now this area we know, right, this is area of ABC. This we can give this as a name C. Okay, so first first the work done from going A to B by path 1, and then we'll find work done from going A to C, then C to B by path 2. Okay, so W1 we are going to find. So W1 is going to be area of triangle plus area of rectangle. So area of triangle is 1 upon 2 base into height. Base is this is this distance CB. CB into height is AC, right? And so this is going to be 1 by 2 plus area of rectangle is going to be uh, length in that length into width, right? So this is going to be this one, we can say, right? So this is going to be this is length P naught into P naught. This height is P naught, right? P naught V naught. So this is going to be CB value is this V naught into AC values 2P minus P naught, right? That is P naught, right? Plus P naught V naught. So this is going to be 3 by 2 P naught V naught, right? This is 3 by 2 P naught V naught. Okay, so this is the work done by W1. Okay, this is the W1. Okay, 3 by 2 P naught V naught. This is by path 1. Okay, now we'll find by path 2 W2. Now we are going to find W2 understand it. Okay, first we are going A to C. A to C, right? There is no area covered, right? Area under the curve. So this is A to this is just a straight line and no area covered, right? So from A to C, the work done is 0 because no area is covered. Now this will go from C to B. C to B, so area under curve is going to be the rectangle, right? Area of rectangle. So this is going to be W2 is area of rectangle, right? And that is going to be area of rectangle. Okay, and that is going to be this one. From A to C there is no work done because no area is covered, and from C to B there is a area covered, that is by this rectangle, that is this height, this length into width. So this is V naught into P naught V naught, right? So this is P naught V naught. Okay, so this is the work done. Okay, so how we are going to get work done in a PV curve, guys? It's a very simple. So path 1 W1 is 3 by 2 P naught V naught, and for path 2 from A to C, C to B, this is P naught V naught. So these are work done, P1 and P2, right? Work done, that is W1 and W2, right? Very simple, guys. I hope you have understood it. Next question we are going to be, so we can easily solve if we get this type of, if we have been given this type of graph and we need to find PV graph, and then we need to find the work done by different path, we can easily get it, guys. Okay, well, next question. Next question is, I'll make a diagram first. Okay, so this is PV curve, this is P and this is B. Okay, so this is P naught and this is 2 P naught. Okay, and here okay, and then this. Okay, this one A to B. Okay, A to B, and this is path 2 and this is path 1. Okay, so for this what we are going, suppose this is C. Okay, so first we are going A to C, then C to B, right? And this is the path 1. Path 1 means now we need to find the work done by path 1 to reach from A to B by path 1 and by path 2 we need to find out. Okay, and let we can say, and which is greater, that's also we are going to find. Okay, and also let we can say P naught V naught equal to W. Okay, we can say, so now we'll find W1 first by path 1. Okay, very simple. By path 1, W1 is going to be this. First we are going A to C, right? The area covered by this rectangle, right? From we are going A to C means the area covered by this curve is this area, right? This rectangle, and so this is going to be this total height. This is this total height. This is this area by rectangle plus this. Now area, and then now the work done from going C to B, but C to B there is no area covered, right? That is 0. So this area plus 0, right? So this is going to be W1 is going to be, this is W1, right? So this is going to be this one, A to C and then B, A to C and then B, right? So this area, so this area is going to be 2. This height is 2P naught, 2P naught, and this height is, this is V naught. My apology, this is V naught and this is 2V naught. Okay, so this is 2P naught. This height is 2P naught V naught, right? This is the W1 work done, right? Because from C to B there is no work done, no area covered, right? So this total area, this is height is 2P naught and width is V naught, right? So 2P naught V naught, this is the area, or P naught V naught we say suppose that is W, right? So this is going to be 2W. Similarly we'll find W1. Okay, so W1 is going to be W1 is this, from going from A to B. A to B means area covered by this curve, right? A to B, area covered by this curve. This is going to be W2 is going to be area covered by this curve, right? So means area of triangle, area is this complete area is covered, means area of triangle plus area of square rectangle, right? So this is going to be area of triangle plus area of rectangle, right? So triangle area is this 1 upon 2 base into height, 1 upon 2 this base is V naught and this is height is P naught, because this height is P naught, this height is 2P naught, right? So this is going to be, and this height is going to be P2P naught minus P naught, right? This is P naught V naught plus area of this rectangle. So this height is V naught and this height is P naught, right? From here this is P naught V naught. So this is going to be 3 by 2 P naught V naught means 3 by 2 W. Okay, 3 by 2 W. 3 by 2 W, right? So from if we are going from this path, from path 1, we'll first go to A to C, right? Then A to C means area covered by this curve, means this area, that is 2P naught V naught, right? And then we'll go C to B, means there is no area covered, so this is 0, right? So this is the 2W. P naught V naught we say we consider that is P naught V naught equal to W, right? Now for this W2, from now for this path we've gone from A to B. Okay, so from path 2, so we are going with path 2, right? So from A to B means area covered by this part, this curve, right? This is equal to area of this triangle plus area of this rectangle, right? So area of this triangle means 1 upon 2 base into height, area of triangle, right? So this is base is V naught and height is P naught, right? Because this is P naught and this is 2 P naught, right? This is 1 by 2 P naught V naught plus this area of rectangle. Area of rectangle is this length in the width. Length is V naught and height is P naught. So P naught V naught. So 3 by P naught. So clearly we can see W1 is greater than W2, right? So we can write that implies W1 greater equal to W2. This type of question can be asked in question. Okay, many questions are asked. So you must know. This is the questions related to PV curve. In PV curve, area under curve is called work done. Okay. So W1 greater than W2. Okay. Next, different processes we are studying. So now cyclic process. Okay, cyclic process. What happens? So we'll solve question related to cyclic process. Okay. Cyclic process. Cyclic process. Okay. So question. I'll make a diagram first. Okay. This one, and this value is V naught, this value is 2 V naught, and this is the curve PV curve. Okay, PV curve, and okay, these are straight line, guys. Okay, this is P naught and this height is 2 P naught. Okay, simple questions, and then this one, and this is this. Okay, this is A, this is B. So we are studying cyclic process. Okay, cyclic process related question. Okay, so this one, this is 2 V naught. 2 V naught. Okay, this is 0. Okay, so now in cyclic process we know, right? In cyclic process, internal energy, change in internal energy is 0. This you must know. In cyclic process, the change in energy is 0. Okay, so now what we are going to do, we will find work done. Okay, now we have to reach from A to B. So now from A to B, the work done reaching A to B, and then B to C. Okay, and C to A. This is cyclic process. Okay, so we are at point A. Again we come at point A by this path. Okay, first we reach A to B, then B to C, and then C to A. This is a cyclic process. In cyclic process, this du equal to 0. In cyclic process, the area for if we are at A and then we go to, we again come to A by this path. First A to B, B to C, C to A. Okay, so then work done is area covered by this path, right? This triangle, right? Area covered by the triangle. That's what we are going to find. Okay, in cyclic process, A to B, B to C, C to A, right? Then in that case, area is going to be area covered by this triangle, ABC. Okay. Well, now so suppose this is one path 2, and this is path 3. Okay, so A to B, this the work done from going from A to B, suppose we say W1, and B to C, that is W2, and C to A, that is W3. These are path 1, 2, 3. Okay, so now we'll find W1 first from A to B. Okay, from A to B. So A to B, the work done, that is W1 is going to be 0. Why? Here there is no area covered, right? No area covered by this curve, right? And also because work done we know that is PdV, right? So volume is constant, guys. Here if you go to A to B, delta V equal to 0, right? Because there is no change of volume. Volume is here, the volume is V naught, here also volume is V naught, right? So that's why dV equal to 0. That's why from going A to B, the work done is 0. No volume change. Okay, W1 is 0. Now for B to C, from going B to C, the work done is going to be area covered by this curve, right? That is area of this rectangle, and that is going to be this length is v naught and height is p naught, right? P naught, p naught, p naught, p naught. Okay, and now C to A. This is cyclic process we are discussing. Okay, C to A, C to A, C to A. You can check, that is C to A W3, right? This is W3 is going to be, we are going C to A, area covered by this curve. This is the area covered by this curve is going to be area of this triangle plus area of this rectangle, right? This is triangle, area of triangle plus area of rectangle, and this is going to be this one. This is going to be -3, because here we know that is, this is going to be minus, this is area of triangle is 1 by 2 P naught V naught, the area of this is P naught V naught, right? This is going to be minus 3 by 2 P naught V naught. Okay, why we have taken minus? Because here we are going C to A, right? In that case, what is happening? The volume is decreasing, guys. Here the volume is 2 V naught. If we reach here, the volume is decreased by V naught, right? So volume at this point is V naught, right? So volume is decreasing, means if volume is decreasing, that means compression, right? Compression means the energy will be, that will be negative. Okay, so I'll show you here the main point I'm going to write. How this is minus. Okay, I'll explain in next page. Okay, next page, this one. Okay, so here, if volume increases, okay, if volume increases, that implies work done is equal to, work done will be positive. Okay, and that is called expansion of ideal gas. Okay, and if volume is decreasing, here volume is decreasing, it means the work done, that minus work done is going to be minus V, sign will be minus VV. Okay, if volume is decreasing, that is called compression. Very important, you need to note down compression. Okay, these points are very important in thermodynamics. Okay, so here in this case, why we have taken minus? Because we are going C to A, the volume is decreasing. Here volume was V2, and when we reach at A, the volume decreased by V naught, right? Only volume remaining is V naught. So because volume is decreasing, then work done is, will be, the sign will be minus, right? Here volume increases, work done is positive, and that is called expansion. Volume decreases, that is work done is negative, and that is called compression. Okay, well guys, so this is the one, guys. Okay, now this one. Okay, so now we'll find total work done. Okay, so this is the W1, W2, W3, right? But it's a cyclic process, right? So total work done W is going to be W1 plus W2 plus W3, right? Because we W1 this plus W2 plus W3. So we'll solve it. So this is going to be P naught V naught minus, okay, I'll write it. So this is going to be, I'll write from here. Okay, so W is going to be W1 plus W2 plus W3, right? W1 is 0 plus W2 is P naught V naught, and W3 is minus 3 by 2 P naught V naught, right? So total work done is going to be, this is going to be this one, minus 1 by 2. Okay, so this is going to be minus 1 by 2 P naught P naught. Okay, so this is the work done, guys. Okay, in cyclic process, and so this is minus, but we are not taking minus. Okay, we'll just mod value. We'll take mod value. So work done is 1 by 2 P naught V naught, means in cyclic process the work done is the because it's a cyclic process, we are starting from A and again reaching A, right? So by this path 1 to 3 path. So in cyclic process the area is area covered by this triangle, right? In this path. So this is this is equal to, we can directly also write it, this is 1 by 2 height into base, that area of triangle, that is 1 by 2 V naught P naught. Okay, okay guys, yes, this is the this is what about the, this is about the cyclic process, guys. Okay, in PV curve, how we are going to solve questions in PV curve is given. Okay, next is, next I'll solve it just like as a question. Okay, so we have given PV curve, guys. Okay, so PV curve, this is V and this is P, PV curve, or we can directly write it's a cyclic process. If you if we so if we have been asked that we need to find the work done, so directly, because it's a cyclic process, then yeah, then that work done is going to be directly area of this triangle, and we can just put the value and get it. Okay, okay, so now this is a question, and question is this is a PV curve given. Okay, and these are different paths given. Okay, from different A and B. This is the path 1 and this is the path 2 and this is the path 3, path 3, path 2 and path 1. Okay, these are path 1, path 2, path 3. Okay, so now obviously from here we can see if work done for path 1 is, work done for path 1 is W1, and work done for path 2 is W2, and work done for path 3 is W3. Obviously we can see W1 W1 is going to be greater than W2. Okay, W2 is going to be greater than W3. W3. Why? Because for path 1 area covered by this curve is going to be greater than area covered by this and area covered by this, right? Simple, right? If it like this would be the area covered. Okay, so by this path area covered is minimum, by this path area covered is greater than path 3, and by this path the area covered is maximum in PV curve. So W1 is going to be greater than W2 and W2 is going to be greater than W3. Okay, very simple. I hope you have understood. This is a cyclic process and we have used 3 paths. Okay, in 3 paths, the work done from going A to B by path 1 is going to be greatest. Okay, and for by path 3 is going to be minimum. Okay, next one thing as a question I'll explain, that is so this is PV curve. Okay, PV curve, this is the path. Okay, and this is A and this is B, guys. Okay, this is A and this is B. This is straight line, guys, not looking, but understand it. This is path 1 A to B for reaching, and this is path 2. Okay, path 1 and this is path 2. Okay, so here we can see by path 1, this is the work done by path 1. This is actually, you can see in this case the volume is expanding, guys. Okay, you can see the volume is, volume here, then it is going to, it is expanding, right here, then it is expanding. So W1 is greater than W2. Okay, W1 is greater than W2. Okay, so because in this case the volume is you can see volume is increasing, here volume is decreasing, right? So this is the one. Well guys, this is about this cyclic process and also how we are going to get work done, find work done in PV curve. Okay, I think there is one more question which I'm going to solve, so give me 1 minute guys. Okay, I'm going to solve that as well. Okay guys, so I'm going to solve this question as well, and then in next class we'll do different processes like isobaric process, isophoric process, isothermal process, adiabatic process. Okay, there is one more question which I'm going to solve for you. Okay, question is, I'll write the question first. Okay, question is if UA is given guys, UA internal energy, UA is 10 joule. Okay, and heat given, heat given, heat given, heat given, heat given, heat given to AC. I'll make a diagram, then it is the AC process. AC process equal to 20 200 joule, right? Okay, 200 joule, 200 joule. Okay, so you need to find out UC. I'll tell you, I'll make a figure, then it will be clear. Okay, so figure is this one. I'll write option first, then I'll write. Okay, options are minus 170 joule, option C is 170 joule, option, this is option B. Okay, option B. Option C is 283 joule, 283 joule, and option D is minus 283 joule. Okay, this is option B. Okay, I'll make a diagram, then it will be clear. Okay, so this is PV graph related question. Okay, so I'm going to make a diagram in PV. Okay, so this is V, this is P. Okay, and this one and this one. Okay, so this is 5, this is 2, and this is 6, this is 6. Okay, This is 15 guys, okay, this is 15, and this is B, and this is C, and this is A. Okay, well, so this is the one. So we have been given here, okay, UA is given guys, okay, UA is given, that initial UA, this is the internal energy at UA at this point, okay, this is given 10 joule. Heat given to AC process, heat given to AC process. So we are going from A to C, okay, A to C, and then for going A to C, the heat given is 200 joule guys, okay, 200 joule, and you need to find out internal energy at this point, okay. So we are going from this path to this path, okay, A to C, okay, and at this point internal energy is UA is given. At this point internal energy UC we have to find, and from the heat given from to reach A to C is given, that is 200 joule guys. Now you must have understood this question by figure guys, okay. So I'm going to solve it. So now we know delta Q is given, that is 200 joule, right? And so we have a formula, that is by the first law of thermodynamic formula, okay. By first law of thermodynamics, we have a formula, that is del Q equal to du plus pdv, right? Or del W, right? So by that we will find the value. So this is going to be, now we can write del Q is given, that is 200 joule equal to du, we can write UC minus UA, right? The change in internal energy, UA, right? Plus delta W. Now we'll find W. This is equation number 1. Okay. Now we'll find delta W. Delta W is PdV, right? And delta W will find. Okay, PdV, or that area. So it's a PV curve. So delta W, the work done is going to be area covered by, because we are going A to C, right? So area covered by this curve, AC curve, means this area. This is, I have already explained, right? So this is area of triangle plus area of this rectangle, right? So this is going, this area is, this height is 10, right? 1 by 2 into base into height. Base is 4 minus 2, 6 minus 2. This width is 4, right? 4 into height is 10. So this is going to be 2 will get cancelled. This is 20 joule, right? And now we'll put the value. So this is going to be from equation 1. This is going to be 200 joule from 1. 200 joule equal to UC value we have to find, UC. Okay, so here one more thing guys, this then this is also, right? This is this one area, this is the area of triangle plus area of rectangle is also here, right? Area of rectangle is going to be simple, plus this height, this is 5 into this width, right? 4, that is going to be 20 plus 20, right? That is 40 joule, right? Now from 1 UC minus UA, right? UA value is given in the question, right? This is 10 joule. So 10, and we can see delta W is equal to positive, means this means heat, that positive is, right? That positive means heat given to this system, okay. Negative means heat extra forms system, okay. So we just leave that, okay. So this one, this is UC and this is 10, okay. UC 10 and plus, I'll explain that later, and dW value is 40 joule, right? 40. So from here value of UC is going to be 200 plus 10 minus 40, right? This is 170 joule. right? So 170 is the correct answer, guys. Which option is matching? Very simple question, right? This is how we'll solve. So yeah, so work done in the PV curve is area under the curve. Okay, that's what we have used here, right? So this is the one. So this one. Okay, so 20 joule, and also we know, right? If dW is positive, means work done by the system. If dW is negative, then work done on the system, right? Okay, so this is 170. So which option is matching? Option B is the correct option, guys. Right? I hope you have understood it. Well, guys, so I'm going to stop here. Okay, and also, guys, I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures, which are going to help you to crack the exams related to physical science. Okay, thank you, guys. Bye now. See you in the next lecture.